Well, good morning, everyone. I hope that everything is well. My name is Michael Myers. I am the manager of the Airports Engineering Division for the FAA's Office of Airport Safety and Standards within the Office of Airports. I want to take this time to welcome all of you, wish all of you a very happy new year. I hope that 2025 has gotten off to a great start for all of you. Um, so as we're here on the 14th day of January, Tuesday, 2025, we're here to, I guess, celebrate the publication of Engineering Brief 105 Alpha, Vertiport design, but also to have an industry day to connect with our partners in industry, our fellow citizens, and those across the world to discuss and socialize and talk about the recent publication of Engineering Brief 105 Alpha. As many of you know, we were under congressional mandate to publish an update of EB105 at the end of calendar year 2024. And we successfully did so. And thank you very much to our team, not just within the FAA and the Office of Airport Safety and Standards, but also to industry. You guys played a very pivotal and crucial role in the development of this guidance. As our subject matter expert, Robert Bassi, and as well as Mitchell Soth in flight standards or aircraft certification will go over some of the details of the update. You will see that we've made some significant changes and strides and improvement from the first edition that was published in calendar year 2022, back in September of that year. As you might notice that the title of the engineering brief is Vertiport Design Supplemental Guidance to Advisory Circular 150/5390-2 Delta Heliport Design. So we made a lot of improvements and revisions in categorizing vertiports and heliports a lot more closely. So we're very excited to be here to engage with you and to talk with you and to address the questions that you have for us on specifically on this engineering brief. So I think we're going to have a lot of fun today and have a great time as Robert and Mitchell brief out to you on some of the changes, and we hear the feedback and inquiries that you have. Keep in mind that the engagement will not stop here. Throughout the year, we're going to have a lot of planned engagement with industry. As you know, this is just interim guidance. We're continuing to grow in as we develop this guidance for Vertiport design. It is a very exciting time to be in aviation, particularly amongst the category of new entrants. As you know, there's a lot going on just within the news and other realms of new entrants as well, in addition to the advanced air mobility industry. So with that said, before I hand it over to our newly hired Deputy Associate Administrator for the Office of Airports, I do want to take this opportunity. Also, I'd be remiss if I did not just acknowledge our fellow citizens in Southern California who are dealing with the horrible wildfire situation. I just want to let you know that our thoughts are with you, as our prayers are, and to everyone else, please keep them in your thoughts and prayers, and continue to be safe and hang in there. Again, with that said, I will hand it over to our newly hired Deputy Associate Administrator for the Office of Airports, Mr. Wayne Hybeck. Wayne, again, just welcome. It's great to have you on board. We know that we look forward to your leadership both within the FAA and industry. So over to you, sir.
Thanks so much, Mike. Thanks. Good afternoon, everyone, and welcome to our Industry Day for Engineering Brief 105A regarding vertiports. As Mike said, I'm Wayne Hybeck, and I'm absolutely thrilled to be returning to the Office of Airports as the new Deputy Associate Administrator. As a previous airport district office manager, I developed a passion for working collaboratively with both airport sponsors and industry to improve our national airport system. I look forward to bringing that same passion with me to my new role. It's an incredibly exciting time to be in aerospace. Robotics, artificial intelligence, hybrid aircraft designs, new propulsion systems, and air taxis are all reshaping and revolutionizing the industry. In October, the FAA issued a final rule for the qualifications and training that instructors and pilots must have to fly aircraft in the powered lift category. It is the first completely new category of civil aircraft since helicopters were introduced in the 1940s. And we in airports are excited to be doing our part by offering this opportunity for engagement with our subject matter experts on the updates made to EB105A. You may have noticed some substantial updates between the draft version released this fall and the final version published in December. Those updates were the result of your feedback. We heard you, and we made the appropriate updates to our standards, which will create a clear pathway forward while maintaining the high level of safety that defines commercial aviation today. We also expect these updates, as Mike indicated, to help state and local jurisdictions as they navigate zoning and licensing processes for these facilities. One of the changes in the engineering brief is the classification of vertiports as a category of heliport. We anticipate this will allow state and local jurisdictions to leverage existing infrastructure requirements with minimal changes. But our work is not done. EB105A remains our interim guidance while we work towards a performance-based advisory circular. To get EB105A across the finish line and issued in the form of an advisory circular, we need to continue our excellent collaboration and engagement with industry. Working in cooperation with our aircraft certification service, we will need access to conforming production aircraft to complete a full array of operational tests necessary to develop performance-based standards. Given your outstanding collaboration to date, I know we can count on your continued engagement as we in airports remain committed to working with manufacturers to ensure our standards reflect the depth and breadth of aircraft coming to market. Again, thank you all very much for joining us today. Back to you, Mike.
Thank you very much, Wayne. We definitely appreciate those remarks from you. Next, I'd like to take the time to introduce our director of the Office of Airport Safety and Standards. Many of you know Mr. John Dermody. So I will hand the floor over to him for a few remarks of his own. So over to you, John.
Thank you, Mike. Hello, everybody. So I'm John Dermody, the director of the Office of Airport Safety and Standards at the FAA. For those of you that I have not met, as Wayne mentioned, we've made significant changes to Engineering Brief 105 Alpha based on all of your input. So let me start off by saying thank you to everybody that took the time to provide us input. We received over 500 comments, and we looked at everyone and made the changes to make this a better product. We wanted you to hear directly from our team on the rationale behind those changes today, and give you an opportunity to ask any follow-up questions that you may have since you read the updated version. Today, you'll be hearing more about things like the reclassification of vertiports as a category of heliports, the new identification markings to leverage time-tested markings used at heliports across the country, and finally, the new downwash caution area surface, the DCA. We're also excited to announce an agreement recently worked between my office, the Airport Safety and Standards Directorate, and the Aircraft Certification Office, AIR. The agreement will establish a mechanism for VTOL manufacturers to demonstrate as an option landing accuracy equivalency to conventional helicopters during their certification process. The ability to demonstrate equivalent landing accuracy will support reduced landing area sizing and non-load-bearing requirements aligned with general aviation heliport design criteria. We know many manufacturers have expressed a desire to integrate our testing needs into the existing certification protocols. We've heard you, and we've established an agreement with AIR to accomplish just that. Finally, you'll hear more about our approach to the future advisory circular. We'll be aligning our standards to move towards a unified vertical lift advisory circular based on input from you all within industry and also from Congress. As we move forward in the next 12 to 18 months, we'll need support from the entire vertical lift industry, including helicopter manufacturers and operators, to help us get to the next chapter of our standards development. So thank you for your participation. Looking forward to your questions today. And back to you, Mike.
All right, Mr. Dermody, thank you very much, sir, for your remarks. In just a few minutes, we'll go ahead and get started with our first presentation. I'll hand it over to Robert shortly. Before we do that, I do want to cover a few housekeeping items. Just to be clear, we know that there's a lot of energy on this. We know that many of you have a lot of questions and inquiries. On this, we will do our very best to get to all of the questions, but in the spirit of being realistic, we know that we will not be able to get to every question. As I previously mentioned, we will be having a lot of engagement with industry, so there'll be plenty of opportunities to engage us with any follow-up questions that you may have or any questions that were not answered. We will ask that you please focus your questions solely on the topic of Engineering Brief 105. We know that there are a lot of topics that surround vertiports or advanced air mobility, the field of advanced air mobility, or the topic of vertical lift aircraft in general. But we want to keep the focus of this discussion on the content of Engineering Brief 105. For those of you, obviously you're listening on YouTube, there is a chat feed feature. So please submit your questions through that platform or vehicle. Again, focusing on the content of the EB. The moment you have a question, please feel free to submit it. You don't have to wait until the end of the presentation. That will give us time to sort through them and get them ready to ask when it's time for Q&A. Again, we ask for your patience. Again, we will do our very best to answer all the questions. We'll answer certainly as many as we can, but we'll not be able to answer all of them. So that said, we will go ahead and jump into the very first presentation. So I will hand it over to Mr. Robert Bassi, our subject matter expert. Many of you, obviously, who are involved are very familiar with Robert, and he's done just an excellent job in leading us with the development of this guidance and working with our team here within the FAA and industry. So without further ado, I will hand it over to you, Mr. Bassi, and we can go ahead and get started with the first topic.
Thank you, Mike. Just give me a second all to share my presentation slides here. Okay, so let's get down to it. So as Mike said, I'm Robert Bassi. I'm within the FAA's Airport Engineering Division. The goal today is to sort through some of the principal changes that have occurred with respect to the engineering brief since the initial draft was released for industry comment. As has been mentioned, we received an overwhelming number of comments, and we tried to be as responsive as we can to a lot of the feedback that we receive. So some of the topic areas we will cover today have to do with the infrastructure classification of vertiports, the vertiport identification marking, landing area geometry, after which we will take a short break, and then we'll return and talk about our agreement that we recently stood up with the Aircraft Certification Service within the FAA, and also the future of vertical lift infrastructure guidance. So as most of you know, and has been mentioned earlier on this webinar, we published an initial iteration of Engineering Brief 105 back in September of 2022. That was a early attempt to provide some prescriptive interim guidance based on limited performance data that was available to us at the time. Since then, we've engaged in a series of operational testing campaigns with OEMs and have been able to glean some relevant and germane performance information on these aircraft that has enabled us to ultimately publish an update to the engineering brief, which we're titling Engineering Brief 105 Alpha, in line with a congressional mandate to do that by the end of the last calendar year. So on the topic of vertiport infrastructure classification, once again, as part of the industry review for Engineering Brief 105 Alpha, we adjudicated an overwhelming number of comments related to making the engineering brief a supplement to the heliport design AC. This push, this momentum that was building, we assessed and we ultimately agreed with this notion of making it a supplement to the heliport design AC. And concurrently, we reclassified vertiports to be a type of heliport, but with distinct requirements. So the FAA classifies heliports into several types. These are based on the intended use of the facility, the operational purpose of the facility, and the design features. The types of heliports that are outlined by the FAA in our heliport design guide are used to provide guidelines for heliport design and operation. So this change to reclassify heliports, per FAA guidance, we will now have 4 types of heliports. So as shown here on this slide, we would have a general aviation heliport. So it's clear to delineate these different terms and explain what they mean. General aviation heliports, which have traditionally served private and non-commercial helicopter operations, will continue to do so. They are typically used by individuals, businesses, or recreational pilots for short-term and infrequent landings. These facilities often have limited services, and they serve as landing areas for activities such as flight training, private transportation, or aerial work, to name a few. We also have transport heliports. Now, these are used for commercial aircraft operations, including air taxi services. You may also see a transport heliport used in an offshore all-rig transportation scenario or intercity aircraft shuttles. They're generally larger than general aviation and are equipped with amenities for passengers, such as a waiting area, and they're typically designed for higher frequency operations and accommodate a variety of aircraft sizes. These facilities, given their aforementioned use, helped originally serve as the baseline for our vertiport design standards. And I know we talked about this severally over the last couple of years as far as how transport category heliports served as the baseline for our vertiport design standards. We also have hospital heliports, and they're designed to serve landing facilities or to provide landing facilities for aircraft or helicopters involved in emergency medical services. So you can think of this in terms of the rapid transport of patients to and from healthcare facilities. They typically feature specialized design elements, such as a larger teal-off or touchdown and lift-off area. There are certain clearances that are provided around the site to accommodate for this special class of infrastructure, and the other safety measures to make this infrastructure suited for quick emergency evacuations. Then we have the vertiport, right, which are now a type of heliport that we are optimizing for the needs of powered lift aircraft and special class rotorcraft with 3 or more propulsors. This distinction is important because our heliport design guide traditionally was written to serve the needs of aircraft with single, dual, or tandem rotors. So these new class of aircraft with 3 or more propulsors require, at a kind of overarching philosophical level, a different type of infrastructure type, right? So we are, once again, treating vertiports as a type of heliport optimized for these power lift aircraft or special class rotorcraft with 3 or more propulsors. As such, they have unique requirements in some cases, emphasis of some, regarding energy charging and infrastructure design. These facilities are designed to handle high-frequency operations and rapid turnarounds based on essentially the use case that we understand in engagement with the industry over the last few years. We expect multiple of these aircraft to be able to land and take off in short succession, requiring more efficiency in passenger and aircraft handling. And all of this will influence the design of the landing area passenger processing, and the charging infrastructure at the facility. Lastly, we have what we term a PPR, or prior permission required heliport. This is really a tangential type of heliport, for which the recommendations in our heliport design AC are not mandatory under federal law. But these heliports, where prior permission is required before landing, are typically designated for private use or restricted use, and they're not open for unrestricted public access. They require operator approval before landing. This change to reclassify vertiports as a type of heliport also aligns with the SFAR language that was recently introduced in the final rule that defines a heliport as a facility that would cater to not just helicopters, but power lift aircraft alike. So that was another impetus for making this change. Lastly, we expect that states, as they begin to explore vertiport infrastructure, vertiport regulations, and classifications, and as those efforts continue to evolve, that those efforts, as we've seen, are being heavily influenced by both federal and local regulations. Heliports have long been part of aviation regulations, right? They've long been a part of how we think about aviation infrastructure and have been subject to standardized regulations. However, to date, when we think about the classification system for vertiports, there's been no widely accepted classification system. As a result, this change to reclassify vertiports as a type of heliport, states can now continue to classify them under existing heliport regulations, which states already have some regulatory familiarity with. So with that, we'll open it up for questions on this particular topic.
All right, thank you very much, Robert. While we're kind of collecting our questions in the Q&A to read, I'll go ahead and just get started and throw some common questions out there. Will future guidance clarify, will future guidance further clarify the differences between a vertiport, vertipad, and vertistop?
That's a great question. Future guidance will indeed delineate the difference between vertiports, vertipads, and vertistops. As a forecast, you can think of a vertiport essentially as that comprehensive full-scale facility that is designed to accommodate multiple VTOL aircraft, providing not only a takeoff and landing area, but other facilities for refueling, recharging, maintenance, passenger handling, and other accompaniments. You can think of a vertipad instead as a smaller, simplified facility that is designed specifically for VTOL aircraft to land and take off. Essentially, it's a landing pad, a platform. It has minimal infrastructure without the same support services or features as you may see on a vertiport. A vertistop, on the other hand, is the smallest and most basic of these facilities for VTOL aircraft. It's essentially a landing and takeoff point without any major infrastructure or services. And they're really designed for short-term or emergency operations and typically serve as intermediate stops on a longer flight route. Once again, future guidance will specifically delineate these items more clearly.
Excellent. Thank you very much. Looks like we got our first question through the Q&A feature. Would the FAA be open to conducting rulemaking for the purposes of expanding the use categories of public and private to include commercial and personal?
Obviously, we understand that rulemaking is a very involved activity as an agency. From a policy and design standpoint, I think that we would be amenable to such rulemaking. But decision to engage in rulemaking is one that we don't take lightly, given the implications of such a process. I do think that in terms of categorization and classification of facilities, such a change is probably at least worth contemplating, just given the use case that has been projected or forecasted for these aircraft in terms of commercial use. So we're not willing to commit to that today, but it's something that we're willing to consider going forward.
Excellent. Thank you. Next question. Why differentiate between vertiport, vertipad, and vertistop when this distinction is not made for heliports?
Great question. We're going to get into that today as far as how we start to harmonize guidance around both types of facilities going forward. So currently, once again, we don't fully delineate in our standard the differences between a vertiport, a vertipad, and a vertistop. As I've just explained, there's that is very much the direction that we're going, and we will be probably going in the same direction for heliports as well, given what we're going to share later today as far as how we progress forward in terms of developing future guidance.
All right, thank you. Next question, will the EB have the force of regulation?
The EB is not mandatory. Go ahead, Mike.
No, I was going to say, I know it seems like there's a lot of questions around rulemaking and regulation. The one thing I will throw out is that obviously we will be under a new presidential administration as of January 20th. So a lot of, I think, what will need to happen is we'll have to see how things play out with what the new administration lays out with regard to that as well before we can certainly know for sure how we'll approach that.
Right. Yeah. No, I would agree with that. And we can speculate, right? But I guess using our crystal ball. But I just the status quo right now is that the EB is is advisory, right? And typically what happens is at the state and local level, a lot of those federal requirements are co-opted and are given the force of state regulations. But the EB is an advisory document and it's not under the force of regulation currently. We'll see how that plays out.
Excellent. All right. Why distinguish between electric and conventional power for power lift when also this dichotomy will also exist for helicopters?
Once again, we're going to see a harmonization in terms of how we think about design criteria and operational frameworks for both vertiports and heliports. So I would say on this question and others like it, please stay tuned to the latter part of the webinar. I understand that currently we don't make those, we don't distinguish in terms of criteria such as that currently because we're trying to go in a performance-based direction for vertiport design since it's been originated in the first iteration of the engineering brief. And the heliport design guidance has traditionally been prescriptive. There's going to be a shift in that to bring those two documents more into alignment.
Perfect. Here's another common question that's been asked a lot. Will there be a classification for hospital vertiports in future guidance, or will it be only classified as a vertiport?
So in future guidance, vertiports will be classified similar, once again, talking about bringing things into alignment, similar to how we classify heliports. They'll be classified based on their purpose, their design, and their usage. So vertiports designed for rapid transport of patients, whether it's medical personnel or supplies to and from hospitals, like I said, typically used for EMS or emergency medical services, will be classified in future guidance as hospital vertiports. Right, these vertiports will essentially be built with the primary goal of trying to facilitate the timely arrival of air ambulances to provide critical care or transport, and will most likely be required to meet specific healthcare-related regulations, as do hospital heliports, with the intent of including specialized requirements for medical flight operations or emergency preparedness, as do hospital heliports. So that, once again, that alignment in terms of how we think about design criteria across heliport and vertiport design is very much underway.
All right, excellent. It looks like we have no more questions coming in through the chat, or through the Q&A chat. So I think we can go ahead and transition on to the next topic.
Okay.
All All right, so just we're doing very good on time. We're looks like we're way ahead of schedule. Um, I again, just a quick reminder, just for everyone to submit their questions through the YouTube chat feature. And again, just in case you don't have the agenda in front of you, I will just maybe just take a quick minute or so to go over the run of show or agenda. So the next topic that Robert is going to cover is the vertiport identification marking. Then he will be covering landing area geometry around mid break or so, or mid session or so. We'll be taking a 10-minute break just so we can all just kind of regroup and refresh. And then Robert and Mitch from Aircraft Certification Service will be covering the agreement that we have between the two lines of business, the Office of Airports and Aircraft Certification within the Office of Aviation Safety. Then we will be covering the future of vertical flight infrastructure through the Future Advisory Circular. As we said that we plan on continuing to develop more robust guidance. And then we'll have some closing remarks from Robert and Mr. Dermody, and that will be the end of our event. So again, I just wanted to give you a heads up if you didn't have the agenda on what some of the topics are. So again, we'll look forward to all the questions that you all will have. So without further ado, we will go ahead and transition into the next topic. And that, I believe, is the vertiport identification marking, Robert.
Thank you, Mike. So in terms of the identification marking used to delineate or to help identify or draw the attention of a pilot to a vertiport, there was some research that was done subsequent to the publication of Engineering Brief 105 in September of 2022. As most of you are familiar with, as part of that engineering brief publication, we introduced the idea of a broken wheel symbol as the identification marking for a vertiport. At about the same time, our counterparts in EASA introduced the V symbol as the identification marking for a vertiport. And in conversations, technical interchange conversations with EASA, we made a determination that the FAA would take on a research effort to investigate the effectiveness of different vertiport identification symbology. We would look at the broken wheel symbol juxtaposed against the EASA V symbol, and then juxtaposed against the heliport H identification marking. And the goal of this study was to obtain pilot feedback regarding the varied vertiport symbology, and the results of that study were to inform the update to Engineering Brief 105 for vertiport design. So pursuant to that, we, the FAA, working with our rotorcraft safety team at Atlantic City, New Jersey, conducted a human-in-the-loop simulation in early 2024. That human-in-the-loop simulation was conducted in the Cockpit Simulation Facility Lab at the William J. Hughes Technical Center. We had pilots that flew approaches instead of really assessing the symbology via replays. That's an important point. These approaches were actually flown by pilots and were not viewed or assessed via replays of the symbologies. The scenarios were flown using two types of simulators, the Loft Dynamics H125 and the R22 Virtual Reality Simulator. There were 18 scenarios that were flown at approximately 3 minutes each. These approaches only started about 3 nautical miles from the vertiport, with 2 approach angle ratios that were applied, 8:1 and a 6:1. The study had 33 pilots in total, all of which had helicopter rotorcraft ratings with varied pilot experience. The research ultimately concluded no significant difference between the broken wheel and the H in identifying the vertiport and controlling the direction of the approach. We did have pilots that also indicated that they were most familiar with the H symbol, one, given that it's a time-tested symbol as it has been applied at heliport facilities over decades. And so this familiarity was largely based on their prior knowledge of the H symbol. So given the findings of the study and congruence with our decision already talked through, to now classify vertiports as a type of heliport, the vertiport identification marking was updated to the H symbol to align with other classes of heliport infrastructure. Now, vertiports are still distinguished, even under this framework, from other types of heliports, with the addition of a VTL marking on the TLOF as part of the identification system for the facility. The application of the VTL marking really followed the precedent of the PVT marking on a heliport, which is used to indicate that a heliport is privately owned or intended for private use only. Similar to the PVT marking, the VTL marking is to be placed in a prominent location on the TLOF and painted in large bold letters on the vertiport surface in order to be clearly visible to pilots approaching the vertiport. This change also simplifies the conversion of a general aviation heliport to a vertiport, as they largely share a similar marking and identification system, except, of course, for the VTL marking. This also simplifies the charting of vertiports on aviation maps so that pilots can identify them as suitable locations for landing and taking off for appropriate type of aircraft, with the key charting information for vertiports now more in alignment with that for heliports. So here's an illustration of what this new symbology would look like. Once again, it's the H identification marking at the center of the TLOF that you are all very familiar with, and that VTL marking prominently placed around the TLOF to distinguish this facility as primarily catering to aircraft with 3 or more propulsors. So with that, we'll open it up for questions.
Excellent. All right, looks like we have a question. Will there be any guidance regarding parking stands and their markings?
We don't have any guidance regarding markings on parking stands currently in Engineering Brief 105 Alpha. We expect to provide guidance on parking stand markings as we think about the next update to the engineering brief, or our performance-based advisor circular, which we're going to go over in greater detail later on this afternoon.
All right. Again, some common questions on this topic. Does the FAA plan to create a unique identification marking for hospital vertiports?
A lot of interest in hospital vertiports. Okay, we plan to have an alternative identification marking for hospital vertiports. Once again, to bring things in alignment with our heliport design criteria. And this is to help ensure that, similar to hospital heliports, hospital vertiports are easily recognized for their critical role in EMS and distinguished from other GA or non-medical heliports. So what does that look like in practice? Right. Once again, similar to heliport design, we would have an alternative identification marking for a hospital heliport that will likely be co-opted directly from heliport design in the form of the H marking painted in red, which is that color that's associated with emergency services and healthcare. And also because that red H stands out, against many environments, which is ensuring high visibility for pilots, flying air ambulances and conducting medical operations. Also, we're going to include that red cross that you're also familiar with in heliport design that will be placed near or integrated with the red H symbol to once again reinforce that hospital or medical function of the facility. So the overarching point is that we'll be co-opting a lot of those, alternative identification marking standards that exist for hospital heliports and applying them to hospital vertiports in future guidance.
All right. Go ahead and ask another question. Could the broken wheel still be used as an alternative identification marking for vertiports?
That's an interesting question. Yes, right. It can be for certain types of vertiports, right? We currently have a provision within our design guidance for the use of optional non-standard identification markings at private facilities. So we would expect to provide guidance around that as we think about iterations to the engineering brief, where a broken wheel can be used, amongst other options, as an optional non-standard identification marking for a private vertiport where prior permission is required for use. Right. Once again, future guidance will address the use of, in general, non-standard identification markings at PPL vertiports. And the recommendation will be made, as it is for heliport design, to compensate for a potentially decreased visual cueing if a non-standard marking is used by increasing the size of the safety area. So another point of alignment, once again, with our heliport design criteria.
Right, thank you. All right, another question came in. Why does there need to be any special marking for VTOL operations? Is there a VTL labeled facility that is not open to a helicopter?
Okay, so good question. So if you have a helicopter that meets the size, right, and weight limitations of a VTL of a vertiport, essentially that helicopter can be able to use the vertiport. So the size and weight limitations are clearly spelled out in the engineering brief, right? So if you have a helicopter that meets those size and weight limitations, that helicopter can use that facility. For helicopters that exceed the size and weight limitations for a vertiport, that helicopter cannot, and it's important for us to delineate, those facilities that are specifically suited for the, for the use of of powered lift aircraft or special class rotorcraft as such. So two-part answer. Yes, helicopters that meet the size and weight limitations for that, a vertiport facility may be able to use it. But for those helicopters that do not, it still remains important for us to delineate such facilities, and that's what the VTL marking serves to do. Also worth mentioning that a vertiport has other accompaniments that a heliport would not have typically, right? The charging infrastructure would be different, in terms of how we manage the downwash, outwash at a facility, in terms of either an operational limitation or an operational area. That, at least, in the interim, will be different for a vertiport than a heliport. There are other issues around noise, right, levels that warrant a delineation between the two. So the VTL marking serves to really just help, once again, delineate those facilities that are specifically operationally suited for these types of new emerging aircraft versus those that are suited primarily for conventional helicopters with single or dual rotors.
All right, perfect. There's a lot of questions around the VTL letters. As it also, if it shows VTL, can we assume? I'll phrase this in a two-part question. If it shows VTL, can we assume that the design standards are compliant for VTOLs? And if there is no VTL, then they are not, such as for DWOW, downwash, outwash standards. The second part is are there concerns that pilots might confuse the PVT, private, with the VTL from a far distance?
Okay.
So I know that was a lot.
Yes. The first part of that question is a pretty straightforward one. The answer is yes. Right. Our expectation, and once again, this is an advisory document, right? But our expectation is that if there's a VTL marking at a facility, that facility has all the accompaniments that we have specifically, and all the accompaniments and requirements that we've specifically specified for vertiport facilities, unique from those for other type of heliports, right? So that is the expectation, and we can continue to encourage developers and industry stakeholders to adhere to our guidance. So the answer is yes to that. In terms of the being able to distinguish a PVT marking from a VTL marking, well, let's just talk a little bit about how the PVT marking came about, right? That marking was rigorously tested by the FAA before implementation. Specific to its conspicuity, there was a 3-mile visibility test that was conducted as part of the FAA's criteria in order to ensure that the PVT marking for a heliport at the time can be clearly identified by pilots from a distance of at least 3 miles. So the text height of the PVT marking was selected pursuant to this test, and it was intended to ensure that the marking is large enough so it can be seen from a significant distance, once again, typically around 3 miles, especially in situations where the pilots are flying at lower altitudes and navigating through urban environments or dealing with low visibility. So that text height was specifically co-opted for the VTR marking to equally ensure that it is visible and legible by pilots at 3 miles out and beyond, and can easily be identified, help identify the vertiport from the air. So we don't have any concerns based on the prior rigorous research that was done that a pilot will be able to delineate between a VTR marking and a PVT marking, from about 3 miles out, which is the required distance, and be able to, adequately identify a vertiport facility as such.
All right, great. Next question. Will there be any standardized colored lighting schema to differentiate vertiports for pilots in low visibility conditions?
We would expect to introduce some of that in future guidance. There's nothing, that research is still pending. That has not been done currently in terms of those sorts of lightings and low visibility operations around vertiports. But that's something that's definitely in the cards as we kind of progress to the next phase of testing.
All right, perfect. All right, looks like we will go ahead and move on to the next topic, and that is landing area geometry. All right, over to you.
Sorry, go ahead, Mike.
No, I said over to you.
Okay, thank you, Mike. Okay, so this one will be fairly straightforward. In terms of landing area geometry, we made one significant change in the engineering brief, which is respect to how we think about the rotor diameter of the aircraft versus the controlling dimension of the aircraft. So for the uninitiated, the controlling dimension is essentially that primary dimension that defines the overall size of the aircraft. Think about its length, its width, its wingspan, and it typically encloses the entire VTOL aircraft projection. That controlling dimension often determines the aircraft's footprint. It determines its clearance requirements and its general design constraints. The rotor diameter, on the other hand, refers to the diameter of the rotors or fans that provide that vertical lift during takeoff and landing. Or more on the nose, in terms of these new aircraft configurations, it's the diameter of the smaller circle enclosing just the propulsion units. So in Engineering Brief 105 Alpha, the rotor diameter is being used for the teal-off and fade-out sizing, and the controlling dimension is being used in nearly all other instances. This change, we feel, aligns with, once again, this is the overarching theme of today's webinar, the alignment with heliport design guidance. This change, we feel, aligns with heliport design guidance. So for some VTOL aircraft, which I guess has been the cause of some discussion industry-wide, the rotor diameter is less than the controlling dimension. This typically refers to a design where the rotors of the fans are smaller than other critical dimensions of the aircraft, such as the wingspan or the overall length. This is common in some VTOL aircraft designs where the airframe or the wingspan dictates the size and performance of the aircraft. The design choice of a smaller rotor diameter is driven by several factors usually. Usually it's by aerodynamic efficiency, space efficiency, noise reduction, safety in some instances, via using a distributed propulsion system. So having smaller rotors can reduce the overall size and weight of the aircraft and make that design more suitable for urban environments where there's space constraints. And also having multiple smaller rotors or distributed fans can allow for more efficient lift distribution and redundancy, which can also improve safety. For those aircraft, they use the rotor diameter and not the controlling dimension for the teal-off and fade-out sizing. This change will support a decreased load-bearing surface size. Also, that distributed electric propulsion system often utilizes smaller rotors that are spread across the entire aircraft. And these rotors are generally more efficient in providing thrust and reducing drag compared to having one or two large rotors. The overall dimensions of the aircraft, especially the wingspan of the fuselage, will be typically larger than just the rotors. Also, another aspect of this change has to do with the design guideline that has existed in heliport design that has to do with the rotor diameter equating to 0.83 times the controlling dimension, or 0.83D, right? And that refers to the recommended safety area around the heliport's teal-off. Specifically, that guideline means that the radius of the safety area around the landing pad would be, or should be more specifically, 0.83 times the diameter of the rotor. However, and this has been shared in previous presentations on this topic, that design guideline does not directly apply to VTOL aircraft for several reasons. One key one is that these aircraft have significantly different flight characteristics when compared to traditional helicopters. They utilize multiple rotors, tilt rotors. They have innovative propulsion systems, as I've already mentioned. This all results in varying rotor diameters and flight envelopes. As such, the design of vertiports requires careful consideration, which is what we've tried to give it throughout this process, on the unique characteristics of these aircraft, including their size, their flight envelope, and the capabilities of their onboard systems. And as such, this 0.83D ratio is not representative of the unique and diverse characteristics associated with these various VTOL aircraft that are being developed. So, in traditional heliport design, the rotor diameter typically incorporates the main rotor's downwash. So that's the turbulent air generated by the rotor blades. It incorporates the landing gear footprint and other parts of the aircraft that may come in contact with the ground or the landing surface, such as the tail rotors or the skids. And the guidance of 0.83D ensures that it's a large enough buffer to protect against the rotor wash, while also accounting for the landing gear and the aircraft's ground footprint. The rotor diameter of the safety area for VTOLs must still incorporate the landing gear or touch points, the downwash from the rotors, but this would be different from helicopters due to having smaller rotors, distributed fans or tilting rotors, and also incorporate other propulsion units. So this comprehensive safety zone is crucial in order to account for all potential hazards during takeoff, landing, or ground operations. So this slide just serves to further illustrate the point that aircraft are being developed in many different configurations, each with varying rotor sizes, varying wing structures, and overall geometries, with some of the most common configurations being that multi-rotor design with multiple small rotors arranged symmetrically or asymmetrically around the airframe. You also have the tilt rotor design, where the rotors or the wings tilt from vertical takeoff mode to horizontal flight mode. And then the all too popular lift and cruise design, where you have separate lift and cruise propulsion systems, where vertical lift is provided by separate rotors or fans and horizontal thrust is provided by wings or additional propellers. In all these designs, the rotor diameter can vary significantly. That's the key point. And in some cases, the rotor diameter may be smaller than the controlling dimension or wingspan of the aircraft. And that is largely what has driven this change, because it addresses the gamut and the variation in design features across the aircraft within the industry. Next slide. And we'll open up for questions.
All right, thank you again, Robert. All right, let's see, I have a few list of a few questions here. When does the FAA expect that DCAs, that being downwash caution area, will be published?
So that doesn't directly relate to this topic, but we can speak to that here. So we expect that the DCAs will be published as we conduct further operational testing throughout this calendar year, which will culminate, in a technical report at the end of this calendar year. And as such, The DCAs will be published, over the course of this year as that operational testing on downwash, outwash for varied vertical lift aircraft is completed.
All right. Is there a pathway to have the FATO final approach takeoff area be non-load bearing?
There is, and we're going to get into that, specifically in the next topic as we talk about our agreement with our aircraft certification service. So that creates an immediate pathway for OEMs that are able to demonstrate, equivalent landing accuracy to helicopters. And also, in addition to that, we will also continue to do our performance-based landing accuracy precision testing for, VTOL aircraft, which we've initiated over the last 12 to 18 months. And that would also help inform the move to a non-load bearing FATO for certain aircraft types that demonstrate a certain level of performance. So we have essentially a two-pronged approach in terms of a pathway. One is via the agreement with Aircraft Cert, which we're going to get into shortly, and also just via our official testing campaigns and updates to our engineering brief to have a more performance-based teal-off dimension and performance-based load-bearing criteria as we learn more about these aircraft flight characteristics and performance information.
All right. Does the FAA have any concerns with vertiports located on top of parking garages with respect to snow removal, structural fire damage, and aircraft removal?
It's an interesting question. Yes, I guess the short answer is yes. The agency does have a concern about that. As we know, given our familiarity with in the use case for vertiports, that facilities that are located on top of parking garages do present unique challenges related to snow removal and structural fire damage, both of which can impact operational safety and efficiency. So we know that parking garages as a whole, especially those in colder climates, can experience significant snow and ice buildup, and that snow and ice can interfere with the aircraft sensors, can affect the landing gear, and can make the vertiport surface slippery and dangerous for aircraft operations. Right? Parking garages just generally have limited drainage systems, and may not be designed for the type of snow removal equipment that are required for a vertiport. So future FAA guidance will indeed try to address the recommended innovative solutions to this issue, such as heated surfaces or some sort of radiant heating system integrated into the vertiport surface that can help melt snow and ice before it becomes a hazard, and some sort of maybe automated snow removal technology, which some of which has come across our desk over the last, I'll say, year. In addition, the future guidance will try to address innovative engineering solutions, such as fire-resistant construction materials, as an example, and advanced fire suppression systems to address fire risk on parking garages, especially those parking garages that have high-density vehicle storage that present inherent risk, once again, of fires due to the presence of gasoline, diesel, and even EV batteries. A lot of these new innovative technologies need to be fleshed out in terms of their efficacy by our technical center. But these are technologies, once again, that have come across our desks and that we'll be interested in investigating over the next several years, and then ultimately introducing them into future guidance, because we do recognize the problem that could exist, or the challenge that could exist with vertiports that are located on parking garages.
All right, excellent. Why is parking for eVTOL set to the FATO size, and why is it required to be dynamic loading while heliport parking is only static?
Right. So in terms of parking on a vertiport, right, it is indeed currently required to be dynamic loading rather than static, primarily driven by the unique and fluctuating forces that are exerted by VTOL aircraft during their takeoff, landing, and hovering operations. So these dynamic forces, think about its downwash, the thrust, the vibration, and impact, are not static and need to be accounted for in the design of the vertiport parking area. right? The dynamic loading that we currently have as a requirement ensures that the surface can withstand not just the weight of a stationary aircraft, but also the repeated shifting stresses that could be caused by aircraft operations, enhancing both the structural integrity and long-term durability of the vertiport. As performance-based data is gleaned on VTOL aircraft taxiing and ground maneuvering, and once again, this is a shameless plug for OEMs to continue to lend us conforming aircraft to collect this requisite data. As we've already shared with the OEMs directly that we need to collect data around ground maneuvering and taxiing, and this is where one area that it will directly impact. So as we get some more of that data, which can also create additional we can also learn about the potential for additional dynamic forces on the vertiport parking area as a result of that data, as well as really understanding, once again, the downwash created by the VTOL aircraft engines and rotors during either hovering, takeoff, landing, and really understanding how the dynamic airflow forces that are generated would potentially impact the ground and the surfaces. We can then expect that the load-bearing requirement for the parking area be relaxed to a static load-bearing requirement for certain VTOL aircraft types. But once again, this will ultimately be driven by aircraft performance. That's why that performance data is so critical for us going forward, addressing some of these requirements.
All right, thanks. Good answer. When TLOF, that's touchdown liftoff dimensions, when they are greater than FAA minimums identified in table 2-1 of the EB, how do we calculate the revised FADO and safety area dimensions?
Okay. So when the TLOF dimensions of a vertiport are greater than our current minimums, the simple answer is that the FADO and the safety area dimensions need to be adjusted accordingly, right? So we have specific guidelines in the engineering brief, as was just alluded to, for required dimensions for a vertiport, specifically the TLOF, the FADO, and the safety area. If you have a TLOF that exceeds the FAA minimums, you will need to just apply that appropriate scaling factor to adjust the FADO and the safety area to ensure that the FADO and the safety area remain compatible with the larger TLOF size. So to double click on this point, I would just say for a larger TLOF size, the FADO will need to increase in proportion to the increase in the TLOF size. And for example, the minimum FADO dimension will need to be scaled by a percentage of the TLOF dimension, right? The safety area must be large enough, just generally speaking, to accommodate for any potential overruns, veering during takeoff and landing, and other operational safety factors. So similarly, the safety area will need to increase proportionally as the TLOF or the FADO dimensions grow. So the truncated answer is just apply that same scaling factor that was applied to the TLOF to the FADO and the safety area.
All right, great. All right, so this is by far the most popular topic so far because there's a slew of questions that have come in. So get ready, take a deep breath. So let's here we go. Will there be a unique obstacle identification surface applied to VTOL operations, and would a VTL marking indicate that operations from the TLOF would be compliant with that controlling surface?
We haven't done the research on the obstacle identification system as maybe our counterparts in EASA have. So that's something that we would look to explore in the next chapter of our testing. We are amenable to that idea, but frankly, at this point, we can't really divulge much information as far as the direction we'll be going in that, because we haven't just done the homework on whether that's something we would want to incorporate into our guidance or not. So I will just say on that point, you stay tuned for essentially future updates to our guidance.
All right, fair enough. Can a heliport without the VTL marking be used by power lift based on size and weight?
Okay, so there's two parts to this answer, right? When we don't stipulate operations, right? This is a design document, right? So in terms of that's really a flight standards question, right? In terms of what our kind of our design recommendations are, Currently our design recommendations are not, unless that facility, unless that aircraft once again demonstrates equivalent landing accuracy to helicopter precision, which is part of the kind of the next discussion as far as how we effectuate that using our new mechanism with aircraft cert. So, our recommendation would be not accept in the case I just alluded to, but once again, we do not stipulate operations. So that's really outside of our swim lane in terms of an ultimate decision on that question.
Okay, perfect. With respect to vertiports, can permanent objects be located in the safety area footprint as long as they are beneath or do not penetrate the elevation of the FADO?
Yeah, so this is another one where we would just be aligning with heliport design guidance, right? So in terms of locating of objects within the safety area, right? That will essentially be especially given the new classification of vertiports now as a type of heliport. This is one where we would just be co-opting the standards and criteria that currently exist within the heliport design and applying them to vertiport facilities.
Okay. How does using rotodiameter RD impact design efficiency compared to using the controlling dimension D?
I don't know that as an argument that it impacts design efficiency. The design efficiency point had to do with the sizing of rotors for certain VTOL aircraft and why in certain aircraft designs you have essentially a rotor diameter that is less than the controlling dimension given the use of smaller rotors. So it doesn't, the design efficiency doesn't have to do with the design criteria at the facility. The design efficiency has to do with why aircraft developers, in their design, considerations opt for smaller rotors that culminate in a rotor diameter that is less than the size of the controlling dimension.
All right. Does this geometry take into account real downwash and outwash characteristics from an eVTOL?
Yeah, good question. That research is ongoing, and we talked a lot more about that during our last industry day, where we introduced the concept of our downwash caution area, that operational area around the facility, that was driven by the outcome of some downwash outwash testing that we did with some eVTOL aircraft over the last 12 to 18 months. So yes, this infrastructure design does account for that, but the point is that also that research is fairly limited at this point. We expect to engage with OEMs over the next several months to collect additional downwash, outwash data to build a kind of a more robust framework around design infrastructure based on that accounts for the downwash, outwash profiles of these aircraft. So there is that consideration now, but we expect that to be kind of further accounted for in future guidance as we collect more downwash, outwash data from a wider gamut of VTOL aircraft.
Okay, good. How does this, I think they're going to say conversion, protect the aircraft from hitting things?
I'm not sure I'm following the question. How does this?
I think they mean the modification that we're making to the geometric layout guidance. I guess what they're inquiring is how is this going to protect the aircraft from hitting anything? I guess the adjustments that we're making to the protective surfaces. That's how I'm interpreting it.
Okay. I mean, I think, the idea is that we have a more comprehensive safety zone around the aircraft, and that would account for essentially, all potential hazards doing ground operations, right? So we're making sure that we have a surface that, incorporates not just the landing gear and the touch points, but other propulsion points as well as the downwash from the rotor. So it's more comprehensive and holistic, and it's more protective of the aircraft and protecting against other potential hazards, such as hitting objects around the facility.
Perfect. All right. Are there specific cases where using the controlling dimension, known as D, is preferred over rotor diameter, RD?
Yes, and those are highlighted in the engineering brief, right? So once again, the rotor diameter is applied for just the teal off and the fatal sizing in terms of the parking, the safety area sizing, other geometric dimensions contained within the engineering brief. We do apply the controlling dimension, right? So it's so yeah, I would just refer to the engineering brief for those unique cases.
Excellent. All right. H has the 0.83D ratio as, oh, I'm sorry. Has the 0.83D ratio been tested with modern aircraft to evaluate its compatibility?
Yes, I mean I don't. Well, I think we can define testing, but we understand how these aircraft are designed. We've looked at the 0.83D ratio relative to the unique and very designed rotor sizes, wing structures, overall geometries of these aircraft, and we've been able to thoroughly and definitively determine that that ratio is not universally applicable to these aircraft. So that research has been done, right? Not just by the FAA, but other parties. So I think it's universally accepted, frankly, that 0.83D ratio is not generally applicable to all VTOL aircraft types, just given their varied design profiles.
Okay. I think I may have skipped over this one. Forgive me if I asked this to you already. How can RD standards be applied to the design of vertiports for larger VTOL aircraft? Did I ask that one?
No, I don't believe so. So what is the
Okay.
question?
How can RD standards be applied to the design of vertiports for larger VTOL aircraft?
I don't see any difference in application. I think they for larger VTOL aircraft or smaller VTOL aircraft, the use of the RD to drive the teal off and fatal sizing remains, right. So once again, there's a limit in terms of size of aircraft to which the EB engineering brief is applicable. That's currently 12,500 pounds. So that's what essentially the specifications that are being talked through today cover, right? If your question is in regards to aircraft that are beyond 12.5, I would say, as we mentioned in the engineering brief, to engage with us directly as far as how you would develop design criteria for those specific aircraft. So I would say aircraft beyond 12.5, please reach out to us directly with those questions, and we'll kind of work that offline, if you will.
All right, thank you. How will you differentiate between RD&D with pad markings at sites supporting helicopters and eVTOLs?
We're going to bring some harmonization to that. So that's part of the upcoming discussion as far as next steps, right? So we understand that there would be a difference for currently for those pads, right? So those pads are uniquely catered to helicopters, and those that would be uniquely catering to VTOL aircraft, as we define it within the engineering brief. But there's going to be some harmonization around that to make sure that how that's displayed on those pads is consistent across the board for all types of heliports, including vertiports.
Perfect. Is downwash outwash a separate drive from RD on vertiport dimensions?
Say that one more time, like a separate drive.
Is downwash outwash a separate drive from roto diameter on vertiport dimensions? Let's see, how can I interpret that one? Driver, how is it a separate driver?
Oh, okay. Yeah, I mean, it is a driver. So I think, as I mentioned, right, it's when you think about the rotor, the safety area, you need to think about what the downwash is from the rotors and making sure that that safety area is large enough to incorporate the downwash from the rotors, whether it's from a single main rotor or from an aircraft with multiple rotors, as you would see with these VTOL aircraft. So it is a driving factor in terms of what the RD or the safety area is for a facility, right? So I don't think it's a separate driver. I think it's one of the drivers.
All right. All right, another good question. A lot of good questions. Is the downwash cautionary area meant to be a physical delineated surface or operationally imposed perimeter?
An operationally imposed perimeter.
All right, that was easy. Are the same RD standards applied to all types of VTOL aircraft, regardless of their size?
Up to 12.5, yes.
12,500
Up to
pounds to
12,500.
speak. Got it. All right. Given AC, 30, I believe they meant to say 5445-46 Foxtrot, which mandates round base cans for lights. How can we develop and certify rectangular cans to support load-bearing, elongated, linear, luminescent panels, given this round can restriction?
I don't think that's pertinent to this discussion. I would say reach out to us and we can talk cans
Yeah,
and lighting separately.
right. That'll be something, a discussion, I guess, pertinent to, relevant to 46 Foxtrot.
Right.
All right. The RD can be smaller than D. They might also share different centers. While RD is used to calculate the T-loft dimension, which center point should be used for marking design?
Say that one more time, Mike. I'm not sure I'm
Sure, no problem. The RD can be smaller than D. They might also share different centers. While the RD is used to calculate the T-loft dimension, which center point should be used for marking design? I guess which point, which center, which centroid, I guess, of the dimension should be used, I guess, to be centered around the marking.
Yeah, I think this is one where we would just apply the same criteria that exists within heliport design, which is you want to mark at generally the center of the essentially that circle, right? But we're not overly prescriptive as far as exactly the point at how you determine what the center of the circle is. I think the way we do it with heliport design is essentially to allow you to use your best judgment as to the center of the circle. I think that criteria would apply in the case of vertiports as well, where where you're trying to determine what center point relates to the kind of controlling dimension of the aircraft.
Okay, thank you. EB105 alpha states opposing size of the FADO and safety area are equidistant to the center of the T-loft. Please expand on the actual field application of this statement.
Okay.
Equidistant, excuse me.
Say that again?
Equidistant.
Yes. Yeah. Once again, this is one that I think is pretty self-explanatory in a lot of ways. So I think the overall point is to make sure that it's you're at equal distances on each side. And this is one where we're not, again, in terms of determining how you configure that dimensionally, we're not overly prescriptive as far as how you do that. Now, as long as you generally meet the spirit of that criteria, which is to again be at equal distances on either side, right? And that's really the level of prescription that we get into as far as how that's determined in practice in the field, right? So generally, how that's been worked in the heliport design world over the last several decades, we would essentially continue to mirror that in vertiport design as far as not being overly prescriptive as far as how that is applied in practice in the field.
All right, perfect. Could reducing the FADO and T-loft area using RD lead to any operational or emergency challenges?
We don't anticipate that, once again, for the reasons we just went over, as far as that the safety zone still remains comprehensive, that even though we are applying RD to the teal-off and fatal sizing, it is still incorporating essentially all the touch points of the aircraft, incorporating the downwash from the rotors, incorporating all the propulsion points. So we're really trying to, although there's this change being made, really alleviate any potential hazards that may occur within doing landing, doing takeoff, and doing ground operations. So we don't anticipate any safety issues as a result.
All right, excellent. Next question, what steps should airports take to adopt their existing heliports to meet these new standards?
In terms of converting a general aviation heliport to a vertiport?
Correct, or adopting it accordingly,
Okay.
modifying it accordingly, I guess.
Yeah. So this alignment or this push towards alignment or just or broader alignment driven by the reclassification of a vertiport as a type of heliport. In practice, that brings about a lot of commonalities, right, in terms of the geometry, landing area, the markings. We've already gone over some of them today with respect to the H, right? But it also, as I've mentioned, they remain unique requirements specific to vertiports, right? So we think that process of conversion has been simplified by way of this change. As an example, if you have an existing heliport that is marked with an H, you can continue to use that H marking, and that becomes that marking for vertiport. You just need to introduce the VTL marking to delineate it as a vertiport, unique, separate and apart from a heliport. But there's other unique facility changes that will be required. Specifically, the introduction of that downwash caution area is one prominent example. Charging infrastructure, unique fire suppression, requirements that are being worked through NFPA. So the full gamut of those kind of conversion details are still being fleshed out both within the FAA and other agencies that are working this issue. But we think that this change ultimately simplifies that process, and more so as we get into what we're going to discuss later this afternoon, which is essentially a unified guidance document that would further streamline that process by addressing more of the commonalities that would exist and harmonizing where practicable between a vertiport and a general aviation vertiport more specifically, and a general aviation heliport more specifically, and a vertiport. So we think, once again, just to kind of summarize this, the changes that we've made have simplified that process, right, overall, but we expect even more streamlined process going forward as we get to a unified guidance document.
All right, thank you, sir. Good job. Looks like there are no more questions. So we made it through this segment. A lot of great questions. So thank you all to the questions that you submitted through the YouTube feed, and thank you to all when you registered. Some of you submitted questions ahead of time. So and again, thank you for those questions as well. So great dialogue, great conversation. So now we'll go ahead and we'll take a 10-minute break. We are running ahead of schedule, which is great. So we will take a quick 10-minute break, and we will reconvene 10 minutes from now. So the time is it's about 1:23 Eastern time PM. So at about 1:33 or so, we will continue. So just a quick 10-minute break, and be back in 10 minutes, and we will continue. We'll pick up after the break. We will talk about our agreement with the Aircraft Certification Service Office. Mr. Mitch Soth will be joining Robert in that presentation, and we will continue from there. So, all right, stay tuned. Thank you. All right, good afternoon or good morning, everyone, depending on where you are. Hope you enjoyed your quick 10-minute break. We are back, and we will go ahead and jump right into the next session. And that is to talk about the agreement between the Office of Airports and the Office of Aircraft Certification Service within the FAA. Again, just want to continue to encourage everyone that you have questions, just submit them through the chat in YouTube. And we will do our very best to get to all of the questions. Without further ado, I'll hand it back to Mr. Bassi, who's been doing a great job at addressing all the questions and presenting. And also wanted to take the time to introduce Mitchell Soth, who is with Aircraft Cert. Hey, Mitch.
Hey.
Thanks for joining us. Really appreciate it. So I will hand you and Robert the floor.
All right, thanks.
Thank you. Over to you, Robert.
Thank you, Mike. So what I'll do is I'll kick off the discussion with a couple of slides, and I'll hand it over to Mitch, and to speak from his perspective. Right. So from our standpoint, we've been grappling with this issue of landing accuracy for these VTOL aircraft, and how that relates to the sizing of the critical surfaces at a vertiport, right? So after much discussion amongst our lines of businesses, we have agreed to work collaboratively to develop performance-based standards, right, for landing accuracy in terms of landing accuracy targets that VTOL aircraft would have the option of demonstrating performance to as part of their type certification process that they're working through with Aircraft Cert. So landing accuracy targets for these aircraft are really crucial in our estimation in order to ensure that these aircraft are safe and efficient and precise, particularly as these aircraft are designed to operate in urban environments or really small constrained landing zones. So given the different and diverse designs, which we've already covered earlier this afternoon for these aircraft and the intended diverse use cases, there is a desire also that the aircraft manufacturers and other stakeholders have shared with us to utilize existing heliport infrastructure and relatively small platforms such as rooftops. Landing accuracy in that environment still plays a really crucial role and it really is a key operational metric. This really includes not just horizontal precision, but also vertical precision, and also the ability of these aircraft to perform safe landings in emergency situations such as engine or power plant failures. So over the next 12 months, the Office of Airports will be developing landing accuracy targets for VTOL aircraft in order to optionally demonstrate, once again, as part of their type certification, their TC, landing accuracy that's equivalent to helicopters. Their targets will encompass two key aspects. One is horizontal accuracy. And what do I mean by that? So that is the lateral deviation from the desired landing point or the landing pad center or the center of the TLOF. For example, and this is an example, so this is not necessarily the direction we're going, right? If you had a 1 meter horizontal accuracy from the designated landing zone, that would mean that the aircraft will be able to land within 1 meter of the center of the TLOF under normal operating conditions. The other aspect of this will be vertical accuracy. That is the elevation relative to the landing surface or pad. So a vertical accuracy target will focus on how well the aircraft can control its descent and land safely within the acceptable height range above the landing surface. This includes ensuring the aircraft can land with minimal deviation in height, even under conditions of engine failure or other anomalies. As an example, again, 1 foot vertical accuracy during landing would mean that the aircraft would land within 1 foot of the intended landing height. So the plan, once again, is to develop and provide these targets to Aircraft Certification Service and provide them precise landing tolerances similar to that of rotorcraft and helicopters. And we will need to investigate over the next 12 months what those targets are by conducting operational tests of helicopters and rotorcraft. And those precise tolerances would then be incorporated into the aircraft certification testing as an option, which Mitch is going to go over. Performance targets that will be developed, will once again give aircraft the opportunity to optionally demonstrate that it can land safely and accurately despite potential power plant and aircraft or engine failures. That's another aspect of this, right? There's normal conditions and there's, in the event of an engine failure. So be it a single motor failure, where the aircraft will still be able to land, or make a controlled landing, right? With a minimal lateral or vertical deviation, or in the case of, say, a total loss of power or multiple motor failures, where the aircraft will still be able to aim to land within acceptable margin of error from the intended landing area, possibly relying on some sort of gliding or parachute system if they're so equipped, right? The information that's then gleaned from the landing accuracy demonstrations that are conducted by aircraft certification will be shared with the Office of Airports, and that will help determine how, how and if a facility with a reduced non-load bearing fatal or a minimum 1 rotor diameter teal-off would be used for said aircraft that were able to demonstrate such landing accuracy, right? And that brings it more in line again with our current general aviation heliport infrastructure requirements. Now, for aircraft that are not willing, once again, it's an option, or if they exercise the option and not able to demonstrate a target landing accuracy during type certification, as aforementioned, we would then employ a performance-based seal-off size that will be included in future guidance. And those requirements for performance-based seal-off will be developed and augmented as VTOL operational testing is performed over the next several months and years. And we would incorporate essentially the observed landing precision during testing, as well as ensuring all the propulsors can remain over a load-bearing surface. So with that, I'll hand over to Mitch to weigh in on the discussion.
Okay. All right. Thanks for that, Robert. As from a overall helicopter suitability standpoint, and I'm using that as a framework because the expectation would be somewhat similar, is that you would end up evaluating the aircraft in terms of the capability of the intended landing pad that you would look at, and whether the vehicle has sufficient visual cueing power capability and control authority to be able to put it down within the accuracy requirements that we're doing. And that would be supportive of what we have in the EB105 type of activity right now. There was a general, and that would be for all the environments that the aircraft is seeking approval for, winds and so forth, and the type of environment, whether it's an elevated helipad or a ground station helipad, because they may end up being different. They have different visual cueing environments. In addition, as there was a question in the other ones where they were talking about some of the helicopter requirements, there is a requirement for Category A helicopters with the engine failure that you would actually have to determine the minimum pad dimension based upon all those factors after an engine failure. And sometimes those minimum pad sizes do end up being larger than what the one that would be driven from the heliport design standard that the aircraft would be suitable for. Those do get published in the flight manual as called out in the advisory circulars 29.2C or 20 Reg 2975. And you're saying, why am I using Part 29 regs? Is because Category A refers back to the Part 29 Category A landing requirements. So that would be the overall expectation of what we would be going through the testing campaign. I don't see it being a whole lot different than what we would be normally expecting usually, but we're going to end up having more information that we would need to share with airports in terms of any adjustments that we'd be making for the EB standard or other activity in that regard. We'll obviously work with the applicants in getting that program down as we go through the test campaign activity through the end of the year and how we end up incorporating that. Okay. I think I kind of covered everything at a pretty high level, Robert. I didn't really have much else, but I did see we're getting some questions already.
So I think, Mike, we can open it up for questions.
Yeah.
All right, perfect. Let's see, will the FAA make performance parameters public?
No, I think go
Yeah.
ahead.
We will share
Robert.
that with Air, and I think Mitch is going to talk about, what decision Air will make in that regard. So
Okay,
Yeah, I would say that we would, because it doesn't really do much good to kind of hide everything and then say, hey, guess what? You didn't meet this. I mean, part of what is going on right now with the updated targets for the teal-off sizes is to take that and go, can industry actually accommodate that? Or can we reduce it? So that's part of what all this activity is about.
okay, perfect. Thank you. Could this agreement and additional testing potentially delay OEM certification?
I don't believe so, because it's not like we'll be asking for a different set of instrumentation requirements than what they would normally be doing for their takeoff and landing performance. And we'd still be asking to go look at all the sites and locations that an environment that they would be wanting to seek approval for.
Okay, great. Here's a good one. Does the FAA plan to conduct similar testing on helicopters?
No, not specifically, besides what I had already mentioned in terms of what we have for minimum pad sizing requirements under 2975 already for OEI conditions.
Okay, all right, excellent. All right, let's see. How will this collaboration impact vertiport design and infrastructure at existing airports?
Well,
Seems to be a
Robert,
high-level question.
I think it depends on what the results are.
yeah, that'll be
Yeah.
that'll be my response. I mean,
Yeah.
We're going to learn a lot over the next 12 months. I'll say that. So, we're going to take rotorcraft and helicopters to a rigorous landing accuracy testing campaign that I'm not sure that they've been under. And that's going to reveal a lot, because that's going to help inform the target. So, depending on how that shakes out, we can see, broad scale changes in requirements beyond just, as we think about future vertiport design requirements. But I think, with all that said, we're going to, however we progress that forward, we're going to do it in a way that is not disruptive, right, to existing infrastructure or existing facilities. So that will be definitely kind of front of mind as we work through that process. But a lot of that will just depend on the outcome of the testing that we would do on rotorcraft to help develop those targets, right? Because that would definitely inform if our heliport design standards that exist today are indeed adequate, right? And also obviously inform how we think about guidance in the future as respects to vertiport specifically. So I'll say stay tuned. We're going to learn a lot.
Mm-hmm.
All right, perfect. All right, you have the public's attention because the questions are certainly pouring in.
Oh yeah.
Are there plans to expand this collaboration to include external stakeholders or manufacturers?
I think this kind of probably a two-prong answer, Robert, because you kind of have your other slides at the end that you're talking to some of that. But
yeah, I think we're gonna cover kind of the broader industry engagement kind of as part of the next essentially topic, but specific to the landing accuracy testing, I'm not sure that we would be expanding this to include as far as the partnership itself to include other stakeholders. I think this is something directly between our office and the Aircraft Certification Service.
All right. What specific factors are being considered in updating the teal-off size requirements for vertical lift aircraft?
Right. So in terms of the performance-based teal-off size, it's really just boils down to what the observed landing precision is for the aircraft, right? And also what, how we can ensure that all the propulsion units remain over a load-bearing surface. So those are the two main factors that will drive that dimension.
As well as the undercarriage containment for the landing gear and stuff as well. Yeah.
All right, very well. Will FAA cert accuracy testing require eVTOLs to demonstrate crosswind capabilities similar to helicopters under parts 27 and 29, for example, 17 knots, all azimuths, HIGE and HOGE.
Yeah, it's hovering ground effect. That
Hovering,
hover out
correct.
of ground effect. Yeah.
Right, hovering out of ground
Mhm.
effect, correct.
Well, as of right now, the the G1s that are getting issued, as well as the powered lift advisory circular that was published, has a 17 knots all azimuth controllability requirement. So I guess the answer to the question of that would be yes.
Okay, all right, great. What methods will be used to test aircraft against the updated TLOF targets?
Well, we probably have to work with each specific applicant a little bit more on that, but generally when I've done this in terms of the category A helicopters, it's been an awful lot in terms of the pilot visual cueing and ability for the profile, as well as the scatter that they actually achieve over the intended target and adjustment that, as Robert was mentioning, he was talking about the 1 foot. I've normally seen that whole undercarriage scatter being quite a large number depending on the pilot's capability and the environment that he's looking at.
All right, thank you. Will the test data be shared publicly or will it remain internal to FAA offices?
I'm going to say probably not unless it's appropriately washed, because there's going to be aircraft capability that may be proprietary that they want to maintain. So I would say it depends, but if it is, it would be in a fashion that would not be identifiable to the specific product.
Yeah, I would agree with that. I mean,
Mhm.
we don't have any intent to share it publicly. But
Yeah.
if we did, it would be completely anonymized as best we can.
Mhm.
All right, good question, good answers. Could you elaborate on your use of the term performance-based?
Robert, I think you were the one using that because they wanted to, from the intent of what a performance-based requirement is how you drive it down into the means and methods aspect is where we're probably going with this.
Right. I would say just in, I guess, in simple terms, it would be requirements that are driven by the demonstrated performance of the aircraft, right? So this would be kind of one where we would give a performance target, give them the option to demonstrate the ability to meet that target and use that as the basis for developing design requirements. So I would say, I know there's a lot of discussion about are these already performance-based or performance-informed? I guess it's a little bit semantics there, but I think the overall point is the performance of the aircraft with respect to its landing accuracy in this case will be the basis for what would what the sizing and the geometric dimensions of the surfaces would be, right? I think that's
Mhm. Yeah.
Yeah, and generally when we use the term performance-based, just within the FAA, we'll have prescriptive standards that specifically lay out how to achieve something. Performance-based says what you need to do, but how you do it is kind of there's flexibility there.
Mhm.
All right. What specific testing methodologies will be used to evaluate aircraft compliance with TLOF targets?
Well, I guess I'm a little bit not knowing Zachary's background. We do an awful lot of takeoff and landing testing normally. And I would be expecting the collecting the data as part of that, and that would be under normal and under failure conditions that we were talking about earlier. So I would be saying that we would be doing it against that and again, against the pilot workload and the performance and coming out with the results from what we would already be doing. Yeah.
All right, excellent.
I think that was the one I just answered. The one that's
Yeah.
Yeah.
Yeah, looks like we had a duplicate that we just
Yeah.
answered.
Yeah.
All right. Looks like there are no more questions. Wait, spoke too soon. In draft engineering brief 105 alpha, both powered and non-powered lift aircraft were considered. Now there is only reference to powered lift. What motivated this change?
Yeah, great question. A lot of that came out of discussions directly with Aircraft Certification Service. That initial delineation in our minds, so delineation between aircraft that featured a transitioning phase, an aircraft that didn't. We thought, based on just some early assessments of, or early and limited assessments of aircraft landing accuracy and their downwash, outwash profiles, we thought that that was a driving, that difference in design was a driving, factor for the differences we were seeing in landing precision and the downwash, outwash profiles, more specifically landing precision, right? And having some really kind of good technical discussions with aircraft certification, we saw that what we were seeing in our testing and what we were extrapolating from that testing in terms of the difference between power lift and non-power lift and how that impacted the landing accuracy wasn't quite what they were seeing in terms of their work with the aircraft more intimately. So based on those discussions, we made that adjustment because our high hypothesis essentially we found was not quite spot on based on the work that Aircraft Cert was doing as they have kind of greater access to the aircraft, obviously as they're working through that and developing those processes with the OEMs directly. So based on those discussions, we made the adjustment, and that just underscores a kind of a larger point for us, right? One, the more access we have to aircraft, right, to be able to conduct the requisite operational testing and production aircraft and conforming aircraft, the more educated and informed our policy decisions are going to be, and so that's why we continue to encourage OEMs to make aircraft available to us so we can make the best educated decisions based on actual performance, right? And two, when we do come across performance data that may deviate from what we've seen based on our initial analysis, we will make those course corrections, which is what we did in this case. So just I think that's a great example of how nimble we've been throughout this process, and also underscoring again the need for access to conforming aircraft. So that's what drove that decision ultimately.
All right, thank you, Robert. If the first eVTOL is certified within the United States by the end of this year and the FAA has not finished the AC connected to EB105, will eVTOL aircraft first land at conventional heliports and FBOs, fixed-based operators, I'm assuming?
Yeah, so Rich can talk more specifically to the certification timelines, but we remain committed to, we have an existing engineering brief, right? And the updates to this engineering brief and development of future guidance will not, negatively impact the timeline for commercial operations for these aircraft. That is a commitment of ours. So if we need to make another update to the engineering brief to address factors that need to be addressed, if we hear if there's actual a high likelihood that an aircraft gets certified within this calendar year, we will make said updates, right? Now we don't, frankly, just speaking frankly, we don't expect that to be the case. But if that's the case, we will. And the development of these targets are being initiated now, right? We've given ourselves to the end of the calendar year to complete the work, but that's really just a very conservative timeline. We expect that over the next several months, we will start to be able to have targets that will be feeding to aircraft cert to facilitate this process, because we understand the timeliness of having these targets in place and incorporated into the certification basis as an option for these aircraft sooner than later.
All right, excellent. Looks like we are all done with questions on this segment. So again, thank you, Robert, for that portion of the presentation, and thank you very much, Mitch, for assisting and joining us. We'll go ahead and transition to our next and final topic, and that is the future of vertical flight infrastructure advisory circular. I imagine this is going to be a popular topic. So let's go ahead and jump into it. Over to you, Robert.
Thank you, Mike. All right, so this is a big one for us, as you can imagine. But this, after much, I guess, contemplation, we've come to a decision, right? But to kind of lay the kind of backstory to this, we had an FAA reauthorization back in 2024 that stipulated that we publish a performance-based vertiport design document by the end of this calendar year, so 2025. And also we begin to make updates to our heliport design guidance in a performance-based direction. So we should transition what has been prescriptive guidance over the last several decades, now dating back to 1959 when it was first published, to a performance-based guidance document. This provision or this stipulation within the reauthorization, we can really consider that one task, right? The legislation clearly indicates, especially the third part of the legislation, the need for these standards to be informed by aircraft performance, and ultimately points to the unification of the guidance and the addressing of dual-use facilities, both new and existing. Right. So with that in mind, the FAA made a decision, right, to pivot away from maintaining separate standards for both vertiports and heliports, and instead pivots to the development of a core set of unified performance-based standards that encompass both heliport and vertiport design, supplemented by specific requirements for different types of aircraft. The timeline to develop this unified vertical lift advisory circular that will be inclusive, once again, of standards for heliport and vertiport design is by June 30th of 2027. Part of what drove the decision is responsiveness, frankly, to industry comments and feedback, right? A unified vertical lift infrastructure guidance document, as we've heard, and I've heard personally myself, as at conferences and part of different focus groups and the like, industry focus groups and the like, is something that the industry has been advocating for a while. There's been a lot of momentum building internally and externally for it, frankly. An industry consensus, as has been shared with us, has been that this streamlined regulation could potentially reduce development times, reduce costs for both vertiports and heliports, and allow for existing infrastructure to be more easily adapted for both conventional helicopters and powered lift aircraft. Okay, so couple important things to mention here as we think about this, right? Although the standard is unified, it will need to really still account for operational characteristics, such as the noise profiles, the charging requirements, the downwash out profiles of power lift aircraft, because those may require different design considerations than traditional helicopters. The approach to design guidance that we're talking about here, we believe is optimal, because it leverages not only the commonalities in heliport and vertiport design, but it also allows for different design requirements that are based on the type of aircraft while also providing a clear path for integrating both technologies and addressing the multiple needs of each sector, right? So when I say commonalities, what do I mean? Right, we know that there are stated operational similarities between these aircraft. That's part of what drove the decision, such as the reliance of both helicopters and VTOL aircraft on vertical takeoff and landing. What does that mean? Both these types of aircraft could have similar spatial requirements, right? And may require similar surface preparations to handle liftoff, landing, and hover, as well as have some similarities in flight characteristics. Both types of aircraft generally operate in confined spaces, urban environments, rooftops, and the like. Both have a requirement around avoiding obstructions during takeoff, landing, and flight. All of this creates a potential for common ground in terms of infrastructure components, such as the landing area and taxiways, as well as other safety considerations. That said, there need to be some adaptations that are made even within that unified standard for aircraft-specific needs that reflect differences in VTOL design, differences in propulsion, differences in size compared to helicopters, the footprint, the load-bearing capacity, the landing techniques of these aircraft can all differ, which may necessitate separate considerations, right? So vertiports, as an example, as another example, will need dedicated charging infrastructure, likely in the form of some sort of high-powered charging station, some sort of fast charging technology, and potentially even a battery swap station. This is a vastly different requirement, has been the precedent for heliports. While, on heliports, there will be refueling stations for aviation-grade fuel, which are what are typically used, right? Some other differences include autonomy, right? We know that the long-run goal for a lot of these power-lift aircraft is to operate autonomously or semi-autonomously. And this brings unique challenges, such as the need for some sort of automated landing system or communication protocol. Heliports, in contrast, generally assume that aircraft are piloted, even though some helicopter operations admittedly are beginning to use some sort of limited automation. Another important delineation as we think about this is noise, right? Noise abatement is important for both, these types of aircraft, but the degree of noise mitigation that's required for VTOLs could differ significantly from conventional helicopters, and that's something that we are assessing within airports and assessing within the agency as a whole. Right. So overall, to support the development of a comprehensive unified vertical lift infrastructure advisory circular, additional research is required, right? Because we need to garner additional performance data for all vertical lift aircraft. So this includes VTOL aircraft and helicopters alike, right? And specifically to feed the development of the first iteration of this advisory circular, we will need to collect performance data around the downwash, outwash of both types of aircraft, your landing precision, which is will be a continuation of a follow-on of what we've done already, engaging with VTOL aircraft OEMs. We will need to do some testing on autonomy, and as I mentioned earlier, testing on ground maneuvering. The data that we collect will then be used by our FAA research team to fill in aircraft information gaps. And this will require also continued coordination within the FAA across various lines of businesses, as well as external collaboration with manufacturers, VTOL aircraft manufacturers, helicopter OEMs, and other stakeholders. And, we have a nugget here that, as we engage in this research effort, the person running point for us on this is Ryan King at our technical center. His email address is here, so please feel free to reach out to him to explore opportunities for research, specifically around these 4 topics, with the goal of, once again, getting as much research done on these topics for all vertical lift aircraft by the end of this calendar year in order to be incorporated or considered for the AC to be published midpoint 2027. So overall, we have and we continue to use as the agency a data-driven approach because we want to ultimately ensure that AAM infrastructure or vertical lift infrastructure standards allow for safe operations. So we remain committed to updating guidance as performance data becomes available. So once again, what's the timeline? a unified performance-based advisory circular June 30th, 2027, at which point the engineering brief will be sunset. We've also remained committed to doing follow-on updates to the engineering brief as needed, once again, to support commercial operational timelines for these aircraft. Also, we remain committed to issuing internal guidance and communications on an ongoing basis. Important also to mention that part of this would be, transitioning our heliport design AC from what has traditionally been a prescriptive, a compliance-based standard to a performance-based standard. That is no trivial task, right? And that's going to require us to focus on setting criteria that are based on helicopter performance and operational needs, rather than the rigid one-size-fits-all prescriptive rules that have been employed in the past. This approach allows flexibility in design, and it better adapts to various helicopter types and operational scenarios. To develop such standards, the research will need to be conducted, as I just mentioned, to develop and determine helicopter performance metrics. The research will also need to involve collecting and analyzing flight performance data for various helicopter models, as well as extensive industry engagement, as well as really researching how the downwash from the rotors from these helicopters would affect the ground surfaces, similar to what we're doing with VTOL aircraft, and also how does that affect nearby structures. So there's a lot of work ahead of us, to get this done, and we cannot do that without your collaboration. So that kind of sums it up, and with that, I'll open it up for questions.
All right, thank you, Robert. And I just want to add, again, we are very eager to work with you all in industry, particularly the OEMs, on research and data collection, while being mindful and respectful of proprietary information. We're very eager to work with you and learn the performance characteristics of your aircraft. That will greatly help moving forward, and the guidance that we further develop for Vertiport design. The more data we receive, the more robust and appropriate our guidance will be. So again, just encouraging you all, as Robert laid out, how to engage us with research. So again, eager to work with you all, and we appreciate the engagement that we've had with you so far. You've played a very critical role in the development in this, in the previous version in this one of the engineering brief, and we look forward to further guidance to publish an advisory circular. But in the meantime, we still want to emphasize that the current guidance on Vertiport design is engineering brief 105 alpha. So that will be the guidance that we'll be using in the interim, in the meantime, until we further develop and update our guidance. So again, thank you to all who put forth the very valiant effort in developing this guidance. All right, so let's go ahead and jump into our questions. Look like we got a good number of questions. All right, will the future vertical flight infrastructure advisory circular also address large UAS with VTOL capabilities? Good question.
Yeah, so we're thinking about this in an iterated way, right? We have a lot of ground to cover here. Just purely in terms of augmenting our Vertiport design standards, consolidating that with heliport design, moving our heliport design standards in a performance-based direction. In the first iteration of the advisory circular is not going to be the end all be all, right? So in the first iteration, no, we're not going to specifically address large UASs. There's an appetite to do so as we further flesh out the guidance in future iterations. There's also a related tangential conversation around stall aircraft, right? Where does that fit in, right? We think ultimately that does belong as part of this unified guidance. Does that become part of the version that's published in mid 2027? I'm not sure that it will, just given the amount of work that's in front of us, right, in the near term. So, but that doesn't mean that follow-on iterations of the guidance wouldn't incorporate some of these other aspects. So, the short answer is in the long run, yes. But is it part of the first iteration that's published in 2027? I don't imagine so.
All right, great. All right, another good question. If vertiports are now considered heliports, why not update the heliport advisory circular instead of creating a brand new advisory circular?
Yeah, I think that's that's a nuanced point. Just as it's been explained, I've been on the slide, we're in effect doing that, right? The publication of this document would essentially jettison the heliport design AC, right? So we're in effect updating the heliport design AC in a performance-based direction, but also incorporating other types of vertical lift aircraft. So we're in effect doing that. We're just calling it something else. That's broader and appropriately so.
All right, thank you. Let's see. How will the Unified Advisory Circle address specific needs of vertiports compared to heliports?
Yeah, we just went over a lot of that. So I mean, there's
still redundant.
Yeah.
Okay. All right. Let's go on to the next one. How does the timeline of 2027 impact the readiness of AM infrastructure?
Yeah, good point. Once again, we remain committed. That's why that second bullet there is important, right? We have an existing guidance document in place. So just this announcement doesn't do away with EB105A. We just published it. We stand by it, and that's our existing guidance document. We'll continue to make updates to that document to support operational timelines for OEMs, AAM infrastructure development, up until the point that in that intervening period until the AC this unified AC is published. So we don't expect there should be any impact, being that we have an existing guidance document in place.
All right, thank you. Next question kind of touches a lot on things you covered again, kind of walking the line between vertiports and heliports. But do you anticipate developing new performance categories for both heliports and vertiports?
Yes. Short answer.
Okay. The different noise profiles between the aircraft can greatly impact the site selection process. Is there any intention in being able to limit sites based on aircraft noise specs? Good question.
I think we're learning a lot more about the noise impacts and the noise profiles. I think that's going to be part of how, at least from a design standpoint, how we delineate across different categories of facilities. That's one of the contributing factors would be essentially the noise profile for that. I don't know that we would essentially impose any limitations, right? I think that would be maybe over broad in terms of our, from how we would approach that. But I think that would definitely be something that we consider and we factor into how we determine what those performance-based categories of facilities would be. One would be what is the noise impact at that facility, a vertiport relative to a heliport, and how is that noise mitigated?
All right, excellent. And also add that that we'll be probably be coordinating with our brothers and sisters over in the planning and programming directorate and our planning environmental division on that as well.
Sure.
Let's see. What specific data sources are being used to update the performance-based standards?
Well, our primary source of data would be the data that's gleaned by way of the operational testing that our research team will be conducting or has conducted and will continue to conduct over the next 12 months, right? So that will be our primary source of data, where we also understand there are other efforts, data collection efforts related to these aircraft. We continue to try to leverage those activities, right? Whether it's within sister agencies such as NASA, the Air Force, to name a few. So those conversations are very much being had on how we can leverage existing activities so we're not duplicating effort. But our primary data collection source would be the research that's being conducted by our technical center.
All right, perfect. How will the FAA involve industry stakeholders in the development of the new standards?
Yeah, as much as we can, right? So we're, as Mike has mentioned earlier, we're going to, this is not the final effort to communicate directly with industry on this topic. We're going to be at conferences. We're going to be engaged in focused meetings with industry stakeholders around this topic. Once the draft document is not published, once the draft document is released for comment, we would almost definitely have another one of these industry days. We would have extensive comment period where these industry feedback will be adjudicated. So industry engagement, right, is critical to the success of this effort, both in the document review stage, but also in the research stage, right, of this effort. So, and it's really going to be a multi-pronged approach, right? Industry engagement on the research front by way of our technical center, industry engagement on the kind of the policy front, either at conferences, part of industry focus groups that have been stood up, and working directly with different industry organizations around this topic. So it's something that we're committed to. So yeah, expect several outreach efforts around this over the next, I would say, couple of years, frankly.
Yes, thank you, Robert. And just to add, we're involving industry not because industry is asked to be involved. We want you to be involved. Again, your performance is your participation, excuse me, is very, very essential to the standards that we put out. So again, yes, stay tuned, and we're always open to feedback and suggestions within all boundaries. All right. Is there consideration for which form use would get priority at a joint use heliport, vertiport, helicopter, or eVTOL operations? For which form to use? I guess I guess to rephrase the question, is there I guess any type of consideration to what would get priority at a joint use, whether it's a helicopter or a VTOL?
Yeah, to be determined. The idea of a dual use facility. My crystal ball, take it for what it's worth at this point. Not having really fleshed this out. With team is whatever is the most demanding aircraft at that facility, be it the VTOL or the similar to being the VTOL or the helicopter, similar to how we think about design standards today. What that critical design aircraft is, whatever that most demanding aircraft is at the facility would take priority in terms of how you what forms the basis for design standards and sizing and load bearing requirements.
All right, perfect. We know that we got a lot of questions. Some may have been outside of the scope or purview of EB105. Again, we'll have lots of engagements. There'll be lots of opportunities to ask those other questions. And just to add, one thing I did not mention, and I think it was placed in the YouTube chat feature. If you have any other questions, whether they pertain to EB105 or not on Vertiports, please send them to our email address at vertiports@faa.gov. That's vertiports@faa.gov. Please feel free to use that email address to send any additional questions that you have if your question was not answered, or if you have a question that is that is in regard to Vertiports, but outside the scope of EB105 Alpha. And that looks like that concludes all the questions that we have. And that is our final session. So looks like we made it through. So great job, Robert. Great job, Mitch. Thank you to everyone who participated, who hung in there with us for the past 2.5 hours to listen in. We hope that you found this very useful. We hope that you found it very enlightening and helpful. Again, this is not the end all be all. We'll continue our engagement in guidance development from here. Again, we encourage you to stay engaged and please reach out to us for any additional questions or engagement that you'd like to have. That said, I will we can circle back both with Mr. Bassi and I'll bring on Mr. John Dermody in a minute just to provide some closing remarks. I'll circle back with you, Robert, so you can provide any concluding remarks that you have.
I would just say, once again, thank you all for joining us today for what I think has been an insightful webinar on the future of vertiport design. All right. I've personally benefited a lot from this interaction. We've heard and explored exciting possibilities ahead in terms of infrastructure and innovation in VTOL technology. As we look to the future, all right, as has been said severally over the course of today, it's clear that collaboration across sectors, whether it's government, technology, aviation, infrastructure, will ultimately be key to unlocking the potential of vertiports and AAM. The challenges are significant, but we think there are opportunities if we work together collaboratively to really reshape this next generation of transportation system. So again, appreciate the participation. A lot of thoughtful questions, thought-provoking questions, and a lot of valuable perspectives that have been shared. It's just the beginning of what we think is a transformative journey. And I'm excited personally, and I know the team is more broadly, to continue to work together to push the boundaries of what's possible in this evolving industry. So with that, I'll turn it over to John.
Thank you, Robert. And thanks again, everybody, for joining, for your active participation. Tons of excellent questions. So thank you for being totally engaged here. Besides the comments we received on EB to transform it into 105 Alpha, which you now have, lots of great questions today. And as Mike and Robert mentioned, it doesn't end here. We have the Vertiports at FAA.gov. If you have questions, feel free to reach out to us there. Reach out to and it could be out of scope questions too. If you have questions that are kind of related, feel free to reach out through that email address. Also, work with your local airport district offices, your ADOs out there. We're in constant collaboration with them. I want to sincerely thank Robert, Mike, and Mitch. Awesome job today. I think, obviously they were very well prepared, did a great job going through the briefings themselves, answering all those excellent questions. So thank you guys. Awesome job there. I think you can clearly see, we're committed to this. We're listening to industry through the engineering brief. We'll listen to you here. We're looking to adapt this as we move on. That's why we have it as an engineering brief right now. As we learn, we're going to continue to update our guidance. That's been our mission all along here, and we've fulfilled our obligations, congressionally, also to industry, to try to move in the right direction. We've been able to pivot pretty readily here to be able to respond to how industry is doing, through the certification process, working with Aircraft Cert. So appreciate, Mitch and your entire office, Aircraft Certification Office, has been awesome to work with. Going through this process, learning together, understanding where we're going in the future, and adapting our standards accordingly. It does, as we work not only domestically here, but we have a lot going on internationally. We're working with ICAO on working groups and job cards related to vertiports. Also working directly with EASA as a regulator in Europe and other civil aviation authorities throughout the world in this brand new sphere. So lots of exciting stuff going on. We're very happy to be part of it. We're committed to working with you all as we move into this next era of aviation. I just want to kind of reiterate again, certainly we do need test data, right? We need to continue our research. We need to work with the OEMs out there to gain conforming aircraft, high performance aircraft that we can do full scale testing on. So please reach out to us. I know on one of the slides we had Ryan King's email. He is leading this at the Tech Center for the testing. So his email is ryan.king@fa.gov. Feel free to reach out to him directly, or you can send it to the vertiports@fa.gov, and we'll be in touch. So with that, just want to thank everybody for participating today, and thank you all for the briefings, for the entire team. And I know there's a lot behind the scenes here, our support staff, Office of Communications, and the Airport Engineering Division, the Emergency Entrance Division, and obviously our friends at the Tech Center. So awesome job putting this together, and thank you all.
Excellent. Thank you, John. Thank you, Robert. Thank you, Mitch. And thank you to Wayne for his opening remarks in the very beginning. So again, Happy New Year. Hope that this new year brings prosperous things for all of you. And we look forward to future engagement. Thank you very much, everyone, and take care. We will talk soon.